In this video, we're going to look at the second aspect of analytical circle geometry, and that is finding the equation of a tangent. And very simply, what you're doing is, if they tell you in the question, what's the equation of the tangent at x equals 1? And this is useful for all function-related questions. I like to immediately sub that in to the equation so that it can spit out a point, so that I just have a point waiting for me. Then the second aspect is working out the gradient of the radius. So now that you've got the point and you've got the equation of the circle, you can work out the gradient of the radius, which is pretty standard, pretty simple. You've probably been doing it for a few years. The only caveat is just to say, keep your numbers in brackets. That's where most people falter when it comes to all things analytical geometry. So just keep things in brackets, and you've worked out the gradient of the radius. You know that the gradient of the tangent and the gradient of the radius are perpendicular to each other, and so the way to do it is the gradient of the radius times the gradient of the tangent should equal -1, and so you'd put your -5/4 in here, take it across. Visually, just to check that you're correct in an exam, it should always be the opposite way around and the opposite sign. So that's the visual check that two gradients are perpendicular. Now that you have the gradient of the tangent, you can go straight into step 4, which is simply y equals mx plus c. You know the gradient is 4/5, and so like all graph related questions, again, whenever you're missing one letter, and remember, you never miss the x and the y, they're part of the final equation. Whenever you're missing one letter in any graph, you just sub in a point. And so I'm going to sub 1 for x, 2 for y, take things across. I get my y-intercept as 6/5, and there I've got my equation of the tangent. I hope that you found this video helpful. If you did, please like it, subscribe to our channel, and share it with your friends.